our appetite for this year's uh, Jack Ware annual quantum update. Jax?
Uh, yeah, here we go. The 2024 State of Quantum Computing presentation for the Silicon Valley Fourth Interest Group. And this one's titled Quantum AI and the Meaning of Life. So here we are. This is, the mainframers have an annual Hug Your Mainframe Day. And here I am hugging a quantum computer, an IBM Quantum System 2. Now, really, most of that is containment, and the computer itself, the quantum processing unit, is the size of a decent sized, you know, silicon chip, and they're made with much the same technologies that your everyday microprocessor is made with, some specialized technologies, and they end up in a very large containment vessel because, of course, they have to be cooled to superconducting temperatures. So here I am at the Thomas J. Watson Research Center in Yorktown Heights, New York, for the 2024 Quantum Developers Conference. This was the first or second one of those, and IBM was kind enough to invite me um, to attend, and I got to see some of their nice toys. And we worked together on some quantum computing projects. Here are the Qiskit advocates. Qiskit is IBM's uh, quantum information science development kit that prepares quantum computations and relays them to various providers, mainly IBM, but it's also used by other competitors of IBM. And because it has pluggable backends, you can make a provider that allows you to send the quantum computations to um, any providers who's got a cloud offering, or to a simulator that they provide you either in the cloud or in software on your disk. I've been a Qiskit advocate since 2019. It's been almost 6 years now. It all really started when I came out in 2019 to Stanford, and I believe it was February, to see you all. And we presented on, that was not my first presentation on quantum computing, but was the only one that we did live, and an IBMer came out with me, and we did a presentation there at Stanford with you all. So I've been a Qiskit advocate since later that year, 2019, and here are a number of Qiskit advocates from all over the world. As you can see, it's a quite international group. Quantum computing is definitely a planetary research project. IBM made their offering public and their kit open source in the build it and it, and they will come philosophy. It was easier to work on the hardware than to figure out how to use it once it was designed. And so they had a need for all the minds of the world to work on quantum algorithms. It's very much like what happened over the centuries as we went from pen and paper to mechanical computing, and all the numerical recipes had to be rethought to be divided up between mechanical computers. And then digital binary computers, of course, we had to rethink all our mathematical recipes again to deal with binary math. And now, in the age of quantum computing, we are having to rethink all our numerical recipes so that we can perform them on quantum computers. It's a very international crowd. I have to tell you, nowadays on Qiskit Slack, probably half the people there are from India. It's an international race. There's the American companies, and there are European companies, and India has very much moved very quickly into this race for quantum computing. And of course, Russia and China are involved. So it's a very international competition, and there are many, many people from all over the world participating in IBM and other American and European companies' efforts. This crowd was very interesting. Uh, as I rode on the bus from the hotel to the event one day, I was sitting next to a fellow and I said, where are you from? And he said, Indonesia. And I said, you're working on quantum computing there? He says, well, I'm a university professor, and we decided we were going to open a course on quantum computing and see who was interested. And I said, was anybody interested? He said, yes, 500 enrolled. So many ambitious, bright young folks from all over the world are very excited and very ambitious to move ahead in their careers into information technology by jumping on the bus of quantum computing, as you can see. Here I am puzzling through the seminar on new Qiskit features, being aided uh, in figuring all this stuff out. We all worked together, and there were competitions and things like that. I wasn't really there for the competition. I was there to catch up on features, advanced features of Qiskit, because um, after I came to see you in 2019, of course, there was a year of excitement, and then in 2020, I had 7 conferences lined up, and the pandemic hit, and so 2019 and 2020 and through half of 2021, I spent mostly working on quantum computing. Business was a little slow in the consulting business, and I really had fallen down the rabbit hole, and I was very excited by all this. And I spent, a couple of years, two and a year and a half, 2 years working mostly on quantum computing, and then business picked up again, and I got more involved with what I do mostly during the day, which is work on IBM business systems with clients. I do programming and modernization. I um, teach how to use these systems and keep them running, that are used to carry out a lot of the world's commerce. And so I had some catching up to do, and I've been catching up over the last 6 months on new advances in Qiskit and becoming more involved in quantum computing, as I see some of the connection between this and what's happening in AI. It's become much more pressing, I think, for me to keep up with this field as I continue in my 70s to continue to learn and continue to stay part of what's happening in information technology today. What's happening in Qiskit is something that we talked about a few times here at Fourth Interest Group, which is that when I described to you quantum assembly language, I happen to be the secretary of the standards committee for OpenQASM, the Open Quantum Assembly Language. And I always said it's not really an assembly language, it's more like a microcode language. It'll be assembly language when the level it's at moves a little higher. And this is what's happening, what they're calling the Qiskit functions library. And this sort of thing is happening with all the people who are doing quantum computing. This same evolution is happening. The basics have been worked out, and they're moving up to higher level operators. Some of these on the screen that I'm showing you were written directly by IBM, but the Q Control Performance Management and the Kedma Kesem um, uh, fundamentals, I would call them assembly operators, assembly language operators that are being coded now, that you can use kind of a high level assembly language operator to do certain functions in quantum computing. They're actually third-party corporations. These are startups that have written these rather complex circuits of quantum microcode. The qubit goes here, and then it twists this way, and then it does that, and then it does that. They've written these things that perform nameable functions. We're getting to the level where we're not just naming what the gate itself does. We are now naming the actual functionality, like perform error mitigation with these characteristics, and it takes parameters. So we are reaching the level of assembly language, what I would call the level of what we would recognize as assembly language in digital binary computing. We're reaching that level now in quantum computing. It's happening. At the conference, Heron is the current offering for commercial customers of IBM's cloud offering. The IBM's cloud offering of quantum computing is generating revenue at this point. And this is the chip they're working on, the Heron, the 156 with the tunable couplers. Not every qubit, it's like the connection machine problem back in the 1980s. Not every qubit is attached to every other qubit. They interact, but they sometimes have to play whisper down the lane. Um, the couplers are individually tunable so that a processor can be tuned for its own error characteristics individually after it's been as it is characterized, and they recharacterize them on an hourly basis and retune the couplers in the cloud. It's so I got to talk some with Jay Gambetta, who is the scientific head of the IBM quantum computing effort, and he said to me, um, "We're going to have a real, marketable device in 3 to 5 years." And he said, I had predicted that, you know, out the same distance a couple of years ago, but he said, I said it on faith at the time, but now I see the path. It's really going to happen. So this is moving ahead very quickly for IBM and for other companies. We had a tour of the quantum lab, and here is a tour on video, and there's a link to it there. As you can see, I've got the link written out, and I've also got a QR code if anybody wants to snap on the screen and look at it at any time. This is about a 7-minute video, um, and a tour of the quantum lab, and it's very detailed. If you really want to see how these machines work, how they work in the laboratory, in the cloud, this is a pretty good detour that shows you the parts and how they set them up and what the lab looks like that they're running out of when you contact them in the cloud. There they see the quantum chip is at the bottom of all that, and all that stuff on the top is the connection technology in to talk to the chip, going through the different levels at different temperatures. At the top, it's 1 Kelvin. At the top is at the top it's like 100 Kelvin, then 10 Kelvin, then 1 Kelvin, then a fraction of a Kelvin as you step down
Yeah,
past those flanges. Um,
pardon, sorry
yes.
to interrupt you. You'll need to sign in to LinkedIn to view the video.
Well, actually, the video's on IBM Quantum on YouTube. I gave the LinkedIn, um, I gave the LinkedIn address because you don't get the ads if you go that way. If you go through YouTube, you get the advertisements. So I gave the LinkedIn one. But if you do tour of the quantum lab, yeah, on the IBM Quantum channel, go for the IBM Quantum channel or the IBM Qiskit channel. IBM Quantum channel on YouTube, you can find this. It's a recent video. It's brand new, last few
Great.
days. IBM, of course, is not the only company. Google, I don't know for sure how well Google's chips are working, but their publicity machine is breathtaking. They snowed the world last week with their announcement, that they'd proven this or that, that it would take 1 billion years to perform some computation, but they could do it on their quantum chip. Um, and basically, IBM, as far as I can tell, without any real inside information, Google and IBM are neck and neck. They're using the same technology, inspired by the same papers, inspired by the same human beings. Among them, John Martinez of the Martinez Group, formerly of University of California, Santa Barbara, and Google basically bought them. Like they basically totally funded them, and that was the basis of their effort. And Martinez, of course, was influential um, in superconducting transmon quantum computing, which is the approach both Google and IBM are using. And as far as I can tell, they're neck and neck. Same number of qubits, same ability, same error correcting. They're claiming an incredible level of error correction at the moment. Google is. That's mostly firmware, and IBM's working the same way. The question is what you can do, how error corrected you can get by adding qubits to the chips and using them as part of the error correction. And they're taking slightly different approaches, but they're working on the same problem. That is the problem of the hour, has been the problem of the hour, which is error correction. And so that what they were really claiming in all this publicity blast that you may have seen in the last couple of weeks is, hey, we've made some progress in error correction. Yes, you have a great, you're doing very good, and the field is moving very quickly, and everybody's working in transmon based superconducting quantum computing. Everybody is, kind of neck and neck on that. IonQ is running on a different approach, and this was one of the first approaches that actually saw some proof back in. They could prove an ion trap quantum computer in the about 1999 era, and the way ion-based ion trap quantum computers work is to actually move ions in space and bump them into each other, and they stimulate them with lasers. Transmon-based quantum computing is something like a transistor, except it's a superconducting device, and the amplitudes are changed by microwave signals. Ion trap quantum computers follow a lot of the same math. They use Qiskit. They're so close that they can perform the same gates. They're so close in their mathematical model that they actually use Qiskit for IonQ, as well as IonQ, ion trap quantum computers, as well as IBM and Google um, uh, superconducting transmon-based quantum computers. But the ion trap, they actually move ions in space. They're in a slot, and they have to play whisper down the lane because they can only bump into their neighbor and become entangled and stuff like that. And they're doing very well. And ion trap quantum computing has the advantage that it's more stable. The entanglement lasts longer. The relaxation time is greater in than with transmons at the moment, but they're slower because you have to move things in space. So it's like a mechanical hard drive versus a solid state device. Xanadu photonic. I don't know if they're getting anywhere with this. There's some indication that this is kind of dead ended, that they're not really making any progress. And I can't swear to that for sure. I don't know. I really have not seen tremendous progress in photonic using photons for quantum computing lately. Xanadu's still in business, and they have a development kit, and which leverages Qiskit among other things. And I really like the photonic approach, and I kind of root for these folks. But I haven't seen any big announcements, in the last year. I don't know if anything's going on there, but of course, not everybody says everything they're doing. So D-Wave, one of the first entries, they're still there. They have specific solvers that kind of they took a different approach. They didn't take the universal quantum computing gate-based approach. They built sort of dedicated devices, and they made early progress very fast. They have limits, but they're still there. D-Wave is still there, headquartered in Vancouver, British Columbia, and they're still cooking along. Just the last week, there was a big convention in Silicon Valley. Um, uh, and there was tremendous international attendance to this. The buzz is getting very great around this, and people came again from all over the world to participate in this convention. There are people who are still doubters about quantum computing, but I can tell you they aren't the people that are making the decisions or spending the money. There's a lot of money being spent on this. There's a lot of nation state involvement in this. It's very much an initiative, as I said, in India. We know tremendous advances have been made in China. They're not always forthcoming with all their advances, but the ones they have stated have been very impressive. So it's really ramping up very quickly. If you really want to understand quantum algorithms, there's a very nice series, Fundamentals of Quantum Algorithms. If you just look that up on the web, there's a link on the slide. I forgot to put up the QR code here, but you can sign, you have to, create yourself an IBM ID, which just means filling out a form. And then you can take the Fundamental of Quantum Algorithms course. And this is the best quantum algorithms course I've seen in all the years that I have been wandering around the Qiskit world since 2016 when I first became involved with IBM Quantum. And the composer is still there. You can still log into the composer and you can still drag and drop quantum circuits as shown here on IBM Quantum Learning. And these are all accessible through, quantum.ibm.com. You can get to all these things through quantum.ibm.com, including and if you just do a Google search for IBM Quantum Learning, you'll save yourself a lot of clicking through from the landing page for IBM Quantum to get to things like this. Now, in the last year, I've gotten drawn kicking and screaming into AI. Okay, so that's kind of been a new thing for me. ChatGPT continues to hallucinate confidently. I love making ChatGPT hallucinate. Here's a hallucination from ChatGPT that I made specifically for the fourth interest group. I asked it, why does the porridge bird lay his eggs in midair? And it says, it's a nonsensical classic. This phrase comes from a humorous monologue by comedian Stephen Wright. Well, that's Stephen wrong there because actually it's a line from the Firesign Theater from don't from We're All Bozos on This Bus about the future fare. And that was the question they asked that confused the computer. They did a computer bit that was based on some DEC computers, and it was very funny. And if you hear it again, it's very funny in terms of very early computing. It's a 1972 album, so the computing was very. They based it on printouts that they had of assembly language stuff, and but they asked the computer, why does the porridge bird lay his eggs in midair, and confused the computer, and it blew up in the comedy record. So ChatGPT hallucinated that was a routine by Stephen Wright. However, ChatGPT does do some things very well. It saved me a good deal of work one week. I had about 45 hours of work ahead of me turning DB2 database functions into Microsoft SQL functions. And ChatGPT, with some errors, took that down to 15 hours. So I had estimated 45 hours. So it was actually quite pleasant. Lesson number one, the more constrained the problem domain is, the more effective AI is. Now, I want to make a point here that I don't think is clear to everyone, that ChatGPT, I'm using a commutative not equals symbol here. They're all not, sort of like Sesame Street. All of these things are not like each other. Okay, ChatGPT is not large language model, is not AI. It uses a large language model. It is an AI application. It is not the definition of AI. AI is the superset. ChatGPT is an application within that superset. Large language models are a component of modern AI, but as Don Golding made clear a few years ago here at Fourth Interest Group, something that's been axiomatic in AI for over 40 years is that reasoning is a small component of real-world intelligence. Most of it, the vast majority of real-world intelligence, is reaction to stimuli. And as you peel back the covers of AI applications, including those that are based around the large language models, you find that there are enthusiasts, and in the Forth community, we're very familiar with people who are enthusiasts who want to do everything in Forth. There are people who want to do everything inside the large language model, like the way there were people who want to do everything inside Prolog, but it's not efficient and it's not effective. Instead, with a large language model does a lot of the interaction and a lot of the basic reasoning, but then the actual work is passed off to other kinds of things like Python SQL programs to talk to databases and things like that. The part of the human brain that does abstract reasoning is a very small part of the human brain. The rest of it mostly has to do with muscle memory and storage. And AI is no different than that. ChatGPT is a very particularly twisted and special purpose AI application. It's designed to suck in the general public and make them have fun with AI. So A, they will spend money, and B, they won't be afraid of it. Okay, so that's what ChatGPT is. The large language models are very interesting. There is a confluence coming with quantum computing because the large language models work by trigonometry. And while digital binary computers, including GPUs, are basically addition machines that happen to do trigonometry by repeated addition, quantum computers are inherently trigonometric. Their abstract model is not a matchstick flip over like a binary bit. It's a sphere, and it's addressed with trigonometric operators in matrices multiplied times vectors. They're linear algebra machines, is what a quantum computer is. It's a linear algebra machine where the individual calculating units are trigonometric. They are matrices of of complex numbers. So there's definitely a intersection coming as quantum computing comes online with AI, because the essence of the large language models, which are so dominant now and are so much in the public eye, these large language models work by calculating the similarity of vectors through trigonometric operators. And I have a picture here of Isaac Asimov, a couple of pictures of Isaac Asimov. That's L. Sprague de Camp and Robert Heinlein and Isaac Asimov on the left, and that's the young Isaac Asimov on the right. He saw so many things in advance. He saw the legacy code problem in 1950. He also saw quantum computing and AI. His positronic robots, whose brains worked by the creation and destructions of positrons along pre-etched pathways in a platinum iridium sponge, resembles very much the approach to quantum computing Microsoft has been working on, called topological quantum computing. His three laws of robotics and the idea of the interaction of the potentials between them, the concept of robopsychology, that even if you designed and etched out the pathways one at a time with a chart, you couldn't always tell what the robot was going to come up with, which was the essence of the drama in his stories and the humor in his stories, is very much a case with the large language models. They are unauditable to a large extent. You can't decompile them at the moment. And they can very much surprise you what you have created once you let it loose. And Asimov saw all this all the way back, 80 years ago. It's pretty amazing how foresightful he was about what the nature of machine intelligence was going to be. And if you really want to get an introduction to large language models, you can do worse than reading the robot stories by Asimov. They very much resemble what we're doing right now. In the scenery is very different, but a lot of the interplay of factors and the peculiar results you can get are very much anticipated in Asimov's science fiction of 80 years ago. If you want to get into AI now, I have two recommendations. If you want to go commercial, go to whatsnext.ai. They have a full developer studio that lets you do all the different things. Use a model, train a model, add retrieval augmented generation to it. You have an AI platform, and then you have the large language model, which is pre-compiled, and then sometimes you can add things to it, sometimes you can't, depending upon the offering. But one thing you can always do is you can add retrieval augmented generation to it, which means you can say, go here and look this up. You can add web searches to it. You can add searches of documents you've provided to it. You can tell it to do SQL queries and write little Python programs that it calls and gets back the answer. All the tools for doing this are in one place commercially in watsonx.ai. I've done some of this stuff with MongoDB, for instance, and you have to go to 7 different companies and sign up for different little offerings to make it all work together and fit together. But you can do one-stop shopping at IBM. If you want to go open source, God bless open source, that's where we all come from, right? InstructLab, I finally found it. I was trying to figure out the open source offering that was really going to comprehend everything I needed to play with all the AI stuff. And here it is, InstructLab. This is kind of new. It's based on some open source models, large language models, and then they give you all the tooling open source up on GitHub to go in and actually train the model itself or add retrieval augmented generation to it, et cetera, et cetera. You have to do much more work here than you would have to do in watsonx.ai. But if you're like me, if you're on the open source thing since the 1980s, there you are, InstructLab. And there's the link for it. And the guy who's the head of it, JJ Asgar, he's kind of the head of the project. He's an IBMer. And they're using an IBM open source large language model called Granite. And that's pretty cool stuff. And I'm working with that now. I've worked on a project with WatsonX, and now I'm trying to do another project with InstructLab and see how far I can get with that. Um, so anyway, I see in the chat a lot of people do remember, do remember um, the Fireside Theater. Unhappy MacNam, Systat Uptime 901. Yes, yes, absolutely. And Kevin's right. When you have a screwdriver, every problem looks like something you want to take apart, right? The breaking of the president. InstructLab.ai. Right, exactly. Kevin, thank you for putting that link up there. Thank you. And remember, the future is fun. The future is fair. You may already have won. You may already be there. I was interviewed on MongoDB podcast, and they said, "Are you afraid for your job because of AI?" And I said, "No. First of all, I'm in my 70s. I'm going to work and do whatever I do till I hit the wall. Um, but you know, I started a long time ago, and an awful lot of things I used to do are automated now. Uh, we do not use MS-DOS debug to enter a program in, as Chuck Moore did when he created Colorforth. We do not enter it into MS-DOS debug an instruction at a time. We have good compilers now to do stuff like that. An awful lot of tedious stuff I used to do a long time ago is now automated. If ChatGPT can automate my conversion of DB2 functions to MSSQL functions, well, that's what computers are for, to automate repetitive tasks. If we as programmers are finding ourselves doing repetitive tasks that can be automated, more power to it. We've always been surfing a wave. We've always had to learn or fall behind. I meet people in the legacy computing field who have 30 years experience, 1 year, 30 times, and they are not learning. And they are very surprised when all of a sudden they don't have a job. But those of us who are still working, we're still working because we kept learning. And we will have to learn new things to stay employed. But here it comes. It's the next thing, AI and its convergence with quantum computing, I foresee happening before the end of this decade. And that's my main message for today. And thank you very much for listening. And the floor is open for any questions.
I have one, Jack.
Sure.
How many R's in strawberry?
How many R's in strawberry?
It's a question that AI answers too.
I see.
It's very reproducible, and we're glad that you passed the CAPTCHA test or the Turing test. I think
Right,
Turing is
right.
out on tour, these days.
Well, I'm a linguist too, and maybe AI got confused because it knew too much. People that get know too much can get confused. There really are two R's in strawberry if you're thinking in Spanish, because there's the ere, which is the one between the T and the A at the front of the word, and then in the back there's an R with two R's. That's a single letter in Spanish. So maybe there are two R's in uh, in uh, in strawberry from that point of view. So maybe
From
AI was
chat,
just outsmarting itself.
from the chat, Yang says, "Have you come across fourth-like shell within DB2?"
No, no, I haven't. Though you certainly can have that. You certainly can use Forth to. If the question is, can you access DB2 from Forth? Yeah, I would say you could do that. Especially now on IBMI, the databasing platform that was sort of a Protestant version of MVS, if you might say. If the ZDB2 is Catholic, then the IBMI is Protestant. It's kind of a revision and simplification of the faith. Yes, there's a driver on IBMI for DB2 called MapAppear, which is named after a uh, the serpent in the tropical island in the West Indies, the fer de lance. Its name in on that island is, on Barbados, not Barbados, the other one, Trinidad. The Trinidad name for the fer de lance is Mapapir, and they named the driver that they wrote after it. And it's a REST API. It's a JSON REST API. So if you can do JSON in Forth, which of course you can do. If you can do a REST API call, you can do DB2 from Forth on IBMI, the IBMI platform, which is, a modern legacy platform. The hardware is perfectly modern. They keep issuing a new processor every 3 years. And it's got a Unix face and a legacy face. And so it's a very modern system that runs some very old code, among other things. And yes, you can write a Forth that could contact DB2 and do DB2 queries on that platform.
They'll have to pin their some prime number of premises to the portal or something. So let me
It's
call for one last question, perhaps, and then let's move on to the next speaker.
I'm curious, Jackson. I noticed that a lot of these libraries seem to be down at the individual level of individual qubits and so on. Is there? Do you have a sense of, is there some fundamental challenge to folks building up to bigger constructs, or they're trying to look for things to do with the small number of bits that we've got, or what's going on there?
okay. First of all, they did start off with small number of bits. The early processors had 5 qubits. They now are up in the thousands, really, in research, and they're online. You can get them in the hundreds. That's commercial. You pay for your QPU seconds and everything like that, but they're there. Okay, so it's partly that it was a small number of qubits, partly that you had to do so much error correction, partly the low relaxation time. You couldn't build very long circuits, so it was basically research, and you had to demonstrate some very, very basic algorithms to convince yourself this stuff was useful, and you had to do them with a very small number of qubits and a very short number of operators. But we're beyond that now. So, of course, what we anticipated, which was that larger and larger operators were going to be created, is now happening.
Cool.
Well, I hear that the extra big and loud timer from ThermoWorks has beeped, so we're out of bounds for further Jackware, as much as we'd like to continue. Uh, Jack, once a year is not often enough. Perhaps you'd come back sooner. Uh, is there something you'd like to say about how to contact you, or maybe I'll pass along anyone that wishes to communicate
Uh,
with you?
it's very easy to find me. I'm all over the web, and the easiest address to get me at, I'm putting
The
into the
chat.
chat,
You're
which you
wonderful.
already know. Thank
So
you very
many.
much.
All right. Thank you, Jack. We
It's
really
always
appreciate
wonderful.
it.
It's always wonderful to come back and see here. As I said to you, Kevin, I feel grounded that I'm still reporting into the same crew that I've been reporting into for 40 years now. Thank you.
All right. To move on, Joseph Stewart,
Hey everybody.
you're on.
Hey
Introduce
Kevin.
yourself.
Oh yeah. My name is Joseph Stewart. You'll see me as Octeta all over the place. I'm a seasoned old C embedded developer, but to be honest with you, I think when I my dad got his HP41 calculator and I saw the 1980 byte article on Forth, I was swept up and loved it. I have managed to sneak Forth into many devices that nobody really. There was no gatekeeper to keep me from doing it, but it was usually only me and the hardware engineers that were using it for reasons that you guys probably all know. Um, anyway, I've been a longtime follower of the SV4th group, starting when I lived in Tennessee, and then when I moved to the Bay Area, I got to go up to a Fourth Day probably in 2011, and then I think I saw you guys at Fourth Day 2023. But I'm down in Los Angeles right now, so that's where I am, adjacent to you. And despite the fact that it's 65 degrees outside, I'm still freezing to death. So what does that say about us down here? I don't know. Um, Kevin, how much time do you? I asked for 5 to 10 minutes. What's your goal for me?
Uh, it's not fourth day. We don't 5 to 10 is fine. 15 to 20 is okay too. Whatever you have before you start rambling incoherently.
Well, that already started, so we'll try to move forward from it. So,
Too late now. So
all right,
let's call it 20 minutes. I'll set the big loud timer.
all right, sounds good.